Today we're going to talk about geoengineering. And geoengineering is a highly controversial approach to the topic of climate change. Specifically, it's a set of proposed solutions to the problem of climate change. And as such, it relates quite closely to the concept of leverage points from systems thinking. So let's look at a simple model of climate change. As we saw before, climate change is all about the interaction of two processes. The first is energy striking the Earth from the sun and the radiation of that energy back out into space. That's represented by this stock and flow structure documenting the flow of energy from the sun to the Earth and then back out into space. The temperature of the Earth will of course be a function of the total amount of energy that accumulates in this stock. Now, the rate at which that energy radiates back into space is a function of the amount of carbon dioxide and other greenhouse gases in the atmosphere, which is represented by this second stock. This stock, concentration of greenhouse gases, will influence the rate at which radiation escapes the Earth. In other words, the more greenhouse gases, the more energy that will become trapped at the Earth's surface. Another way to say this is that there is an inverse relationship between the stock of greenhouse gases and the flow of energy out of the system. What determines the concentration of carbon in the atmosphere? Well, it's the carbon cycle, of course. That balance between respiration by living things and the uptake of carbon dioxide by plants and algae over time. To think about the carbon cycle in modern times, however, we have to add another flow. Anthropogenic emissions, or the greenhouse gases that enter the atmosphere as a result of human activity, are a major contributor to this dynamic. So we'll represent that by this flow called anthropogenic greenhouse gases. The two major factors contributing to this flow of anthropogenic greenhouse gases are methane emissions from agriculture and carbon dioxide, and increasingly methane emissions, from the production and combustion of fossil fuels such as coal, oil, and natural gas. So the system is very simple, but it captures the major dynamics of climate change. Of course, we want to make this system work better, which in this case means keeping the temperature from rising to a level that has negative impacts on human well-being. So we need to figure out how to manage this system. And from a systems thinking perspective, we need to begin looking for leverage points operating within the system. And of course, the first two are staring us right in the face: emissions from our energy and agricultural systems. These two factors represent a huge amount of leverage on this system. So we'll just change those values, right? We'll lower our emissions, so we'll use less energy, and we'll eat less meat, right? Let's just do that. Are you there, guys? Are you still there? I just said we'll eat less meat and drive fewer. Okay. Of course, the problem is that just because something is a place where a change would have a large effect on the system, that doesn't mean that it's a place where it's easy to make a change. And in fact, when we approach energy usage, we see that this is the case. When we approach food, this is the case. Changing patterns of food consumption or energy use at the societal level run right up against the interests of some of the most powerful stakeholders in global society: agribusinesses and the oil industry. And there is a lot of money at stake. And it's not much better with the diffuse stakeholders called the general population, where you're up against the entrenched habits within a society. Cars are convenient, hamburgers are delicious, and structural problems, such as the fact that many American cities have been built around the idea of individual car travel. That's the way that most people get around most of the time. So we know what the leverage points are, but it's very hard to apply the leverage that we have. So what do? Do we just give up?